Hey, this is Presh Talwalkar. In this video, I want to share two fun problems that I saw online. Let's get started with the first problem. We have a right triangle and an inscribed circle. Suppose that the inscribed circle has a radius that's equal to 12. The inscribed circle is tangent to the hypotenuse, and it divides the hypotenuse into two lengths of A and B. B is equal to 44. The question is, what is the length of A equal to? Let's work this problem out step by step. I first want to review a key principle, which is that a pair of tangent line segments from outside a circle must have equal length. So suppose we have circle O and we have a point A that is exterior to the circle. Let's construct one tangent line segment, we'll call it AB, and we will construct another tangent line segment, AC. We will show that AB is equal to AC. To see why, let's construct the radius OB. Since AB is tangent to the circle O, we must have that AB is perpendicular to BO. Let's do the same thing for the other tangent line segment. Let's construct the radius OC, and since AC is a tangent line segment, OC and AC must be perpendicular to each other. Now, let's construct AO. This will have some length we will call W. Now, suppose that OB and OC have the same radius length R. We now have two right triangles, AOB and AOC. These will be congruent to each other because we have two lengths that are equal to each other and we have a right angle. We can readily compute the length of the tangent line segments and we will see that they are equal to each other. Therefore, we have shown that AB has exactly the same length as AC. Let's now use this principle to solve the problem. So let's return to the problem where we have a right triangle with an inscribed circle. The inscribed circle has one point of tangency on the hypotenuse, it has another point of tangency on the shorter leg, and it has a third point of tangency on the longer leg. We can now consider the vertices of the triangle and consider the principle of equal tangents. So from this upper vertex of the triangle, we have one tangent line segment to the circle. We can also see if we swing this around, we have a pair of tangent line segments, and by our principle, they must be equal to each other in length. So this tangent line segment also has a length that's equal to A. Let's do the same thing for another vertex. Here we have a tangent line segment from this vertex, and we know that its length is equal to 44. If we swing it to the other side of the triangle, we have another tangent line segment, so its length must be equal to the other length, and this will be equal to B is equal to 44. Let us now construct radii to the other points of tangency. Construct a radius to the point of tangency on the shorter leg. We will form a right angle with the radius and the leg. And we will do the same thing for the longer leg. So here we have a radius to the longer leg and we have a right angle here. We have now constructed a quadrilateral, and it will be easy to see that this is a square. So all sides of the square will have the same length, which is equal to 12. We are now ready to solve the problem. Let's focus on the larger triangle and consider the lengths of the legs and the hypotenuse. The shorter leg will have a length that's equal to A plus 12. The longer leg will have a length that's equal to 12 plus 44, which equals 56. And the hypotenuse will have a length that's equal to A plus 44. We now consider just these lengths, and since we have a right triangle, we must have the square of A plus 12 plus the square of 56 is equal to the square of A plus 44. All that remains is to solve this equation. So let's focus on just this equation. To get started, we will expand both binomials and simplify the squares. Now we have a squared on both sides, which will cancel, and then we group like terms. This equation simplifies to be 1344 is equal to 64a, which then gives the result that a is equal to 21. And that's the answer. Let's now proceed to problem 2. We have a right trapezoid with an inscribed circle that's tangent to all 4 sides of the trapezoid. One of the parallel sides has a length that's equal to 3, and the other side has a length that's equal to 7. The question is, what is the radius of this inscribed circle? To get started, let's construct some radii. Construct a radius to the height of this trapezoid. We have a point of tangency, so we have a right angle here. Construct a radius to the top side of the trapezoid to its point of tangency, so we have a right angle here. And construct a radius to the bottom side's point of tangency, so we have a right angle here. We have now constructed 2 squares which will be equal to each other. Each side of the square will be a length of the radius, so each side will be equal to r. So we can go ahead and label that the height of this trapezoid will be r plus r, which equals 2r. The bottom side of the square also has a length that's equal to r, so this length on the bottom side will be equal to r. The same is true for the top side of the square, so we will go to the top side and we can see that this length is equal to r. Now let's calculate the lengths that are obtained by taking the entire side lengths and subtracting these radii lengths. So on the bottom side of this trapezoid, if the entire side has a length equal to 7 and we subtract r, we will be left with a length of 7 minus r. On the top side of the trapezoid, we know the entire length is equal to 3 and we subtract r, so this length is equal to 3 minus r. So let's take these lengths and identify them in the diagram. We will now use our principle of equal tangent lengths. So let's get started. We have one tangent length here from one vertex of the trapezoid, and if we swing it up to this side, we have another tangent line segment from that same point, so we know these lengths will be equal to each other, so this tangent line segment will have a length that's equal to 7 minus r. Let's do the same for the top side of this trapezoid. Here we have a point and we have a tangent line segment. We can swing this to another point, so we have another tangent line segment. So these 2 lengths will be equal to each other. So this length will be equal to 3 minus r. Now we will construct a right triangle. Let's take the height of this trapezoid and translate it over the length of the shorter side that's parallel. So let's translate it to the right 3 units. Notice we now have a length that's equal to the same length of the height, which is equal to 2r. We now take this top length of 3 and translate it to the bottom side. So if we take the entire bottom length, which is 7, and we subtract 3, the length we are left with is 7 minus 3, which equals 4 units. Let's now clean up the diagram and focus on the right triangle that we have constructed. One leg has a length of 2r, another leg has a length equal to 4, and the hypotenuse has a length that's equal to 3 minus r plus 7 minus r, and this simplifies to be 10 minus 2r. We therefore have the equation that the square of 4 plus the square of 2r is equal to the square of 10 minus 2r. All that remains is to solve for r in this equation. So let's go ahead and simplify this equation. The square of 2r is equal to 4r squared. We can then expand the binomial. So 16 plus 4r squared is equal to 100 minus 40r plus 4r squared. The 4r squared will cancel out, so we are left with the equation that 40r is equal to 84, and this means r is equal to 21 over 10, which equals 2.1 centimeters. And that's the answer. What a wonderful problem. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.